Hello friends, what's up? My name is Raghav and today's video is for all my buddies who've entered grade 9. So congratulations on passing grade 8 and a warm welcome to grade 9. You would have seen a small change in science that in grade 8 you study general science and in grade 9 science basically breaks down into physics, chemistry and biology, and this kind of leaves everyone with a lot of questions in their mind as to how are these branches of science different. So we'll be learning physics today, and I will be starting off with the chapter on motion. But before starting off with motion, let us try to understand what physics is, what are physical quantities, and why is physics so important. What is the reason behind studying physics in grade 9? So let us start off with a very general discussion on the subject itself. So if I talk about physics, to me, physics is a branch of science. Absolutely. Agreed. It's a branch of science. Just like chemistry and biology, physics is also a branch of science. But physics is something that deals with quantification of natural phenomena. Like in your grade 8, you studied about gravitational forces. So if you drop an object, it will fall towards the center of the earth because of gravity. And you did not learn how to measure this gravitational force in grade 8. But in grade 9, you will be learning the skill of measuring all these forces in the chapter gravitation. So, physics basically deals with quantification of natural phenomena. You all watch cricket, right? You see your favorite bowlers, your favorite fast bowlers. You see them on the field. They deliver their overs at the speed of 150 kilometers per hour or 140 kilometers per hour, right? So they're just throwing a ball towards the batsman. It's a natural phenomenon, but this natural phenomena is quantified. Why? Because there is a small bar on the screen which tells the viewers about the speed of the ball. That so and so bowler threw a ball at 140 or 150 kilometers per hour at this batsman. So, physics involves quantification of natural phenomena. And as I mentioned, quantification of natural phenomena, it also emphasizes on physical quantities. Now, these quantities are measurable. You can measure these quantities, just like temperature, right? It's measured using a thermometer. The speed of your car, your mass, or the weights that you lift in gyms, right? So they're all measurable. They're all measurable. So some examples of physical quantities could be mass, length, time, temperature, right? So we'll be dealing with a lot of physical quantities, and we basically categorize physical quantities as scalar and vector quantities. Now let us distinguish between scalar and vector quantities, and let's see how are these quantities different. So physical quantities can be categorized as scalar and vector quantities. Now scalar quantities depend only on magnitude. Basically, scalar quantities are independent of direction. Let me give you an example. Let's just say you have a 10 rupee coin, a 20 rupee coin, and a 5 rupee coin. Now you place all the three coins in one of the pockets of your trousers, right? In another scenario, you place one coin in one pocket and two coins in the other pocket. Does the amount of money change? No, right? So, scalar quantities are independent of direction. So I can cite some examples over here, like mass, like temperature, as I mentioned in the previous example, money. So moving to vector quantities are dependent on direction. So there is both magnitude and direction in case of vector quantities or vectors. Now let me give you a very simple example. I have a block over here of some mass, and I want to push the block towards my right. So let's say I apply a force over here. The block will obviously tend to move in this direction. And if I want to push the block towards the opposite side, right? If I want the block to move towards the opposite side, I have to exert a force like this, and the block will move in this direction. So this makes me come to a conclusion that force is a vector quantity. Velocity is a vector quantity. We'll learn about velocity and force in the later course of physics, but just for your understanding, so that you get a feel of what scalar and vector quantities are, scalar quantities depend only on magnitude, whereas vector quantities are dependent on magnitude as well as direction. Now let us move to our chapter on motion. You've all studied about motion in your previous grades, in your grades 6, 7 and 8. And when I say the word motion, the first thing that comes to your mind is movement. You say that anything that appears to move around you is in a state of motion, right? So this moving object around you, or this moving particle around you, undergoes a change in position with respect to time. So that makes us come to the second point of this mind map, that motion is nothing but a change in position with respect to, I'm writing WRT, time, and stationary objects. So I'll underline time and stationary objects. I absolutely agree with this statement that if there's an object that is moving, right, it is at some point A and then it moves to a certain point B. So this movement would have taken over some interval of time, right? So this change in position with respect to time is called as motion. Example, let's say you start from home and you have to go to school, and your school is 10 kilometers away from home. So it takes you some time to reach school, right? So you undergo a change in position with respect to time. Also mentioned that motion can be called as change in position with respect to stationary objects. Now let me give you another example. Let's say you're sitting in a room. If you're sitting in a room, do the walls of that room tend to move? No, right? If I talk about the walls, do they move with respect to you? No, absolutely not. But if there is someone stationed on Mars or Jupiter or Saturn, right, for that person, the Earth appears to rotate about its axis. And for that person, since the Earth is rotating, the room in which you are sitting and the wall that was static for you will appear to move for that person. So this makes us come to another very important feature of motion, that motion is relative in nature. Something that is not moving for you might be in a state of motion for somebody else, right? So you need a certain reference. You need a certain reference to say whether an object is in a state of motion or not, right? So motion is relative in nature. You cannot express motion in absolute terms. So these are certain characteristics of motion. And previously I was talking about physical quantities, right? They are measurable in nature. Let's just say I want to measure the distance between Delhi and Noida. This is Delhi, and this is Noida, sector 18. And let's say the path length between Delhi and Noida sector 18 is 6 kilometers. Over here, 6 is the magnitude or the numerical value of this path length, and kilometer is the unit. It is the unit. Now, this unit serves as a basis for comparing physical quantities. For example, I write my height over here, 6 feet 1 inches. That's my height. And let's just say I write someone else's height, which is 216 centimeters. Can you compare these two heights? Can you say who's taller based on just looking at these numbers? No, right? Why? Because the units are different. In one case, I've mentioned the height in feet and inches, and in the other case, I've mentioned the height in centimeters. So I have to compare these two values of height, and I have to make sure that the units are the same. So I can convert either my height in centimeters, so I convert 6 feet 1 inches to centimeters, which is 185 centimeters. Now you can compare who's taller, or I convert 216 centimeters into feet and inches. So that will give me around 7 feet 2 or 7 feet 3 inches. So now when the units are same, when this basis for comparison is same, you can say that I am tall, I am shorter, and the other person whose height is 206 centimeters is taller. So I can just write the other person's name as Great Khali. Okay. Now let us move to two very important physical quantities that are very well connected with the topic of motion. I just mentioned that motion refers to the change in position of an object with respect to time. Now, if there is a change in position of an object, right, that means that there is some path length between the 2 points, the point from where the object has started to move and the point where the object has ended its movement, right? So there is some kind of a path length between these 2 points. So this path length, or this total path length between these 2 points, is called as distance. So let us say I have 2 points A and B. So I can move from point A to point B like this. I can move from point A to point B like this. I can move from point A to point B like this. I can move from point A to point B like this. But if I am to reach point B at the earliest, I can also move from point A to point B like this. So you see the red colored curves over here? All these red colored curves, 1, 2, 3 and 4, all these red colored curves basically give you information about the path length between points A and B. So I have taken different path lengths, but still I have reached point B, right? And you must be wondering, I have drawn a black line over here between the points A and B, because this black line was nothing but the shortest path between points A and B. And this shortest path is called as displacement. This shortest path is called as displacement. Distance, on the other hand, is the total path length between 2 points. Now the unit of distance is meters, or you can just write m. That's the standard unit of distance. You can also express distance in kilometer, miles, yards, etc. Now let us compare these two physical quantities, distance and displacement, and let us see the difference between these two quantities with the help of a very simple and interesting case study. Let us say that there's a person who's wanting to learn how to drive. So this person joins a driving school for assistance and help, and he starts off his classes on Monday. So let's just say on Monday he starts from a point A, right? Moves 3 kilometers away from A, reaches a point B, and from point B this person reaches a point C, which is 4 kilometers. Now, as the level went up at the driving school, on Tuesday, this person thought of again starting from point A and ending at point B, and then this person thought of taking a turn from point B to point C like this, and this path length between points B and C is also 4 kilometers. Now let us have a look at Wednesday. Now this person has undergone some transformation, and this person has plugged in some confidence to take a perfect perpendicular 90-degree turn. So this person has taken a 90-degree turn. So this angle is 90 degree, and again the path length between points B and C is also 4 kilometers. Now on Thursday, this person starts from point A, moves to point B and covers approximately 7 kilometers, and then from point B this person moves back to point A. So this person is basically moving back to point A, and his journey is over. Basically this person learned how to reverse the car. Then on Friday this person did something different from Thursday. What he did was he started off from point A to point B, and the path length between these points is again 7 kilometers, and from point B this person went back by 3 kilometers to a point C. Alright, let us look at our last case of Saturday, because Sunday the driving instructor said I need a break. So on Saturday this person starts off from point A, goes to a point B, again this path length is 7 kilometers, and from point B this person moves back to point C, and this path length from point B to point C is around 10 kilometers, let's say. Now let us follow a very simple practice of finding out the distance and the displacement for all the 6 cases starting from Monday. So if I talk about the distance, The distance from point A to point C is nothing but 3 kilometers plus 4 kilometers, which gives you 7 kilometers. And if I am to find the displacement is also 7 kilometers. Because there is no other path over here. The object is moving in a straight line. The person who is learning to drive is driving along a straight line, right? So the distance and the displacement in this case become equal. You can make a note of this, that if an object moves along a straight line, then the distance and displacement will be same. Talking about Tuesday, again, if I add up the paths AB and BC, I get the total distance. So this person again covers 3 kilometer plus 4 kilometer, which gives 7 kilometers over here. And displacement would be AC, which is the shortest path between points A and C, right? This black dotted line is the displacement. And we all know that in a triangle, sum of two sides is always greater than the third side. So AC for sure is less than 7 kilometers. Alright, now let us have a look at the case of Wednesday. The person again moves from point A to point C, and the total path length or the distance covered by the person from point A to point C is nothing but 3 kilometer and 4 kilometer added together. That gives 7 kilometers, which is the same as Monday and Tuesday. And take a look at this. The direction of this person's car is changing every day, but the distance is not changing with change in direction. And this makes us come to a conclusion that distance is a scalar quantity and displacement is a vector quantity. So if I am to calculate the displacement is side AC, which you can calculate using Pythagoras theorem, and that is nothing but the square of hypotenuse is equal to the square of the altitude and the square of the base added together. So if I am to find AC is square root of 3 square plus 4 square, which is 9 plus 16. Square root of 25 gives me 5 over here. So displacement is 5 kilometers. Again, let us have a look at Thursday. So in case of Thursday, the person starts from point A, moves to point B, right, and goes back to point A, and the distance between point A and B, or the path length between point A and B, is 7 kilometers. So the total distance that this person is covering, starting from A, going to B and coming back to A, is 7 plus 7, which is 14 kilometers. So distance is 14 kilometers. But the displacement over here is 0. Why? Because the initial point of that person, the point from where that person actually started, it coincides with the final position of the person, right? There is no path length between the initial and the final point. The initial point and the final point are coinciding. This makes me come to a conclusion that the displacement has to be 0 kilometer. Let us calculate the distance and displacement in case of Friday. Now the person travels from point A to B and reverses back to point C. So he covers a distance of 7 kilometer plus 3 kilometer. So I add both these values together and I get this. But if I am to calculate the displacement, which is the shortest path between A and C, I need to know about this path. If the entire red line was equal to 7 kilometers and this person reverses along the same path by 3 kilometers, so I am left with AC. Which is the displacement undergone by this person, which is 7 minus 3, and it's equal to 4 kilometers. Let's calculate the displacement for Saturday. So let's calculate the distance first. So the person starts from point A, moves to point B and goes to point C, reverses from point B and goes back to point C. So if I calculate the total path length from point A to point C, it's going to be 7 kilometer plus 10. So this is 17 kilometers. If I want to calculate the displacement in this case, now I started off from point A. Let's say point A was my 0 mark, right? And I moved towards the right of the 0 mark, something like a number line. Something like a number line where all the numbers to the right of 0 are positive and all the numbers to the left of 0 are negative. I started off from this point, right, and I considered this direction to be my positive direction. And when I reversed from point B, I moved to point C like this. So I moved towards the left of my 0 mark. So this is approximately, yeah, 10. The green line is 10 kilometers and this is 7. So my portion labeled as CA, which is my displacement, will be equal to 7 minus 10, which is minus 3 kilometer. So looking at all these cases, we can draw one conclusion, that if an object is moving in a straight line, then distance and displacement are always equal. Looking at the cases of Monday, Tuesday and Wednesday, we can also come to a conclusion that distance is independent of direction. Displacement, on the other hand, can be 0, it can also be negative. Apart from being positive, it can also be 0 and it can also have a negative value, right? So distance and displacement are equal only in the case of linear motion. You can make a note of this. And displacement can be positive, negative or 0, which makes displacement a vector quantity or a direction dependent quantity. So let's differentiate between the two terms and then we'll have a look at a couple of numerical problems as well. So distance is scalar. It's not dependent on direction. It can never be negative. Can never be negative. To get the total path length, you keep on adding the individual path lengths, right? So how can you get a negative number? So distance can never be negative. It's a scalar quantity and its unit is meters. You can also write it like small m over here. So it's a scalar quantity, it can never be negative, and it is defined as the total path length between 2 points. Okay. Now talking about displacement. Displacement, on the other hand, is slightly different. The only similarity between distance and displacement is their units. Both of them have units of length like meter, kilometer. So displacement is a direction dependent quantity, as we saw in the case study. It's a vector quantity. It can be negative, can be 0 or negative, right? The unit can be in meters, and displacement is the shortest path between 2 points. So I hope the difference between distance and displacement is clear. So let's have a look at a couple of numerical problems. So let us have a look at this numerical problem over here. Yeah. So this question says an athlete completes one round of a circular track of diameter 200 meters in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes and 20 seconds? So an athlete completes one round. So in this question, you are given that the athlete is completing one round in 40 seconds. So one round in 40 seconds. And can we calculate the number of rounds at the end of 2 minutes 20 seconds? So 2 minutes and 20 seconds can be written as 120 seconds. 2 minutes can be written as 120 seconds plus 20 seconds, which is 140 seconds. So in 140 seconds, let's say the athlete completes X rounds. The athlete completes X rounds. Now let us find the value of X. So I cross multiply 140 into 1 is equal to 40 into X. So 40 into X gives me 140. X is basically equal to 14 by 4, which is 3.5 rounds. So if I have a circle over here, right, this is the diameter of the circle, this is the center of the circle. So if I start from point A, right, I move from point A, I go back to point A, that is one full round. I do the same process once again, that is another round. I do the same process once again, that is the third round, and now it's 3.5 rounds. So I have to consider the half round, which is starting from point A and it moves back to point B over here. So after 3.5 rounds, I will be at point B. And I am given that the diameter of this track is 200 meters. Right? So it is very clear that the shortest path or the displacement at the end of 2 minutes 20 seconds or after completing 3.5 rounds, the displacement is the diameter, which is 200 meters after 3.5 rounds. If I want to calculate the distance or the total path length for these 3.5 rounds, I know that the circumference of a circle is 2 pi r, and I am given r as 100 meters, right? Because the diameter is 200, so the radius becomes 100 meters. So I multiply 2 pi r by 3.5. Why? Because the athlete has covered 3.5 rounds, right? So I multiply 3.5 by 2 pi r. So 3.5 into 2 is 7. I can take pi as 22 by 7, and I know the value of r as 100 meters. So I can cancel out 7s. I get 2200 meter as my total path length or my distance. So I hope this question is clear. Let us move to another question. So this question looks a little tricky. I'll give you a couple of minutes to solve this question. You can solve this question and you can write your answers in the comment section, and then we'll solve this together. That's how we learn, right? So we'll solve this question together. I'll give you some time to think about it and solve it in the comment section. You're supposed to find the distance when the object moves from point A to point B, and you're also supposed to find the displacement for the same. The object is moving from point A to point B, so you're supposed to calculate the distance and displacement. And since you've learnt that distance is the total path length, it is the total path length. So what I do over here is I add up all these black lines, not the dotted ones, the dark black lines. So I start from point A, I move to a point C, D, E, F, G and B. So if I want to calculate the distance, I basically add up AC plus CD, because that's the total path length, right? Plus DE plus EF or FE plus this semicircular arc. I can write this as arc FGB, and that's my total path length or my distance. So let's just plug in the values of all these lengths. So I know that AC is 2 meters, CD is 3 meters, DE is also 3 meters, EF is also 3 meters, and if I have to calculate the circumference of this semicircle, so I know that the circumference of a circle is 2 pi r. So if I want to calculate the circumference of the semicircle, so I have to multiply half with 2 pi r, and r over here is equal to 7 meters, which is the radius of the semicircle. So r is 7 meters. So I add up all these values. I get 3 plus 3 6, 6 plus 3 9, 9 plus 2 11, 11 plus pi into 7, because r is 7, and let us take pi as 22 by 7, 22 by 7. So 7 and 7 get cancelled, and I get 33 meters as my distance, or the total path length. Now, if I am to calculate the displacement, or the shortest path between the points A and B, I can calculate displacement as AC plus CF plus BF. Very, very simple. AC is again 2 meters, CF is 3 meters, because this is a square. If all the three sides CD, DE and EF are 3 meters, CF also has to be 3 meters. And the diameter of this semicircle, if the radius is 7, the diameter has to be 14. So if I add all these path lengths together, AC, CF and BF, I get the displacement, which is the shortest path, that is 2 plus 3 plus 14, which is 14 plus 3 17 plus 2 19 meters. So that's the displacement undergone by this party. I hope you like this lesson. I hope you like this lecture. And if you like this lecture, please hit the thumbs up button. Do subscribe to my channel for more stuff coming soon. And till then, take care, stay safe, happy learning, stay healthy and keep smiling.